Today's lesson is on the fundamental counting principle. When given multiple events, there are a couple of ways to list possibilities. You can either create a tree diagram, or you can count each possible outcome. If you only want to find the number of possibilities, you can use the fundamental counting principle. Which is when you multiply the number of options for the first choice times the number of possibilities for the second choice times the number of possibilities for the third option. So let's take a look at some examples and create some tree diagrams and compare using the fundamental counting principle. Okay, in example 1, we're going to make a tree diagram and list all the possibilities. If you go to the snack bar to buy a bagel and a drink for lunch, you can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or a sports drink. So let's start by creating our tree diagram. Let's use PB to represent our plain bagel. Let's use BB to represent the blueberry bagel, and RB to represent the raisin bagel. From each of these choices, we're going to extend 2 tree branches because there are 2 choices for drinks, water and a sports drink. So I'm going to use W for water and SD for sports drink. So after listing all of those, you can simply count up the results at the end of the branches to get our total possibility. So if I take a look at that, we have 1, 2, 3, 4, 5, 6. So there are 6 options for lunch. Now if we want to list all of them out using words, you can do that. I'm still going to use PB for plain bagel and W for water. There's one choice. And I'm simply reading along my branches. So if I go back to the plain bagel and I go the other direction, I have the choice of getting a sports drink. Moving on to blueberry bagel, I could pair that with water or a sports drink. And finally, the raisin bagel, I could have water with that, or I could instead choose a sports drink. Again, there are 6 options. Using the fundamental counting principle down here at the bottom, we had 3 choices for bagels, 2 for drinks. 3 times 2 is 6 total options. So you can see if we simply want to know the number of options, using that fundamental counting principle is much quicker. Let's take a look at another example. When we're getting dressed for school, we have the option of a red, blue, or white t-shirt, jeans or sweatpants, and tennis shoes or sandals. Let's see how many different options that we can come up with as far as our outfits. So I have the choice of a red t-shirt, a blue t-shirt, or a white t-shirt. From there, I have 2 choices as far as if I want to wear jeans or sweatpants. So I'm going to go ahead and use J, and I think I'll just use S for sweatpants to make it a little bit easier. And white t-shirt, jeans, or sweatpants. I also have an option of shoes. I can choose to wear tennis shoes, T, or S for sandals. So each one of these branches then would have 2 more for tennis shoes and sweatpants. You can see how we can run out of room rather quickly. But once we're all done, we can simply just count them. So if I counted all of these options here, it should match what we have for a list, and then also down here for the counting principle. So if I'm going to go ahead and list these, let's say I have my red t-shirt. I have the choice of wearing jeans and tennis shoes with that. But if I want the red t-shirt, I could also choose to wear jeans and maybe sandals. Again, with a red t-shirt, let's say I want to wear sweatpants, I could pair it with tennis shoes or sandals. So with each t-shirt, it looks like we're going to have 4 different options. Here are all the options with the red t-shirt, and I would do the same thing with the blue t-shirt. I could pair it with jeans and tennis shoes, or I could choose the jeans and sandals. Maybe I want to wear sweatpants instead. So I got blue t-shirt, sweatpants, and tennis shoes, or blue t-shirt, sweatpants, and sandals. Again, 4 options. I also have a white t-shirt that I could choose jeans and tennis shoes, or the white t-shirt, jeans, and sandals. White t-shirt, sweatpants, and tennis shoes, or the white t-shirt, sweatpants, and sandals. Altogether, it looks like there's going to be 12 options. Let's do a double check with the fundamental counting principle. I have 3 t-shirt options, 2 pants, and 2 shoes. 3 times 2 is 6, times 2 is a grand total of 12. And again, if you counted these over here, these options, you would get 12. One last example, you toss a penny 4 times. How many different outcomes are there? Okay, well, tossing a coin, for our very first toss, we only have 2 options. It has a head and a tail. So that is our first toss. For the second toss again, I might want to write smaller here, I'm again going to have heads or tails for both of those. We're going to do a third toss and even a fourth toss. So at each one of these branches, I need to add another 2 and input heads and tails at the end of those. So at the end of 3 tosses, I have 2, 4, 6, 8 choices, but I need to toss that coin again. So each one of these branches will have another H and T at the end of it. If you're already thinking about what we're going to end up with, great. Let's see if you are correct. It is very difficult to get all of this stuff in here. So when we're all done, if you counted them up, you should get your grand total, and it should be 16. Again, first toss, we have a head or a tail. Same for both the second, third, and fourth. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. You can also list all of your options just by simply following your branches. So if I followed the branch here and went straight across, I would have one option of being all heads. So there will be 4 of those. And if I continue to list everything, I will have 16 different options. So I'm going to go ahead and list all of those options. And again, to do this, you're simply just following your branches, making sure you're coming up with all of the different scenarios that could happen. Again, T stands for tails and H stands for heads. So you can see I've started to list all these out. I still have quite a few more to actually list. But I will try to get them all in here. And if you're wondering what the very last one should be, it should be the same as the first one, except it will be all tails. And there's the last one, 4 tails. All right, so keep in mind using the fundamental counting principle is much quicker than doing the tree diagram or listing them if you're only interested in knowing how many options there are. So again, you can do that by multiplying, like we did here. the first option. There are two different results. Same with the second, third, and the fourth. Multiply them together and got 16. Thank you for watching.